Alright, this is our final example from section 2.5. I apologize that I did not get it added in to the previous video, but that's okay, right? Alright, Francisco needs to find the height of a building. Now we have done this before with two separate measurements, but this one is set up a little bit differently, so make sure that you read the problem closely. Our sketch is going to look different than what we have done previously. From a given point on the ground, she finds that the angle of elevation to the top of the building is 74.2 degrees. She then walks back 35 feet. From the second point, the angle of elevation to the top of the building is 51.8 degrees. So the further back we get, the lower that angle of elevation, because we're looking out more than we're looking up. From these two measurements, these two different angles of elevation, we're going to be able to find the height of the building. Okay, so we've got a sketch. First things first, we start with our sketch. Here's our building. We're trying to find the height of the building. Now the building's not going to change, right? So that's our consistent value. We're forming right angles. Our first measurement, she finds the angle of elevation to the top of the building is 74.2 degrees. So from wherever she is, this angle of elevation is 74.2 degrees. So that's my first measurement. And then she backs up. Now we are assuming that whatever she's measuring from is going to be on the ground, because we're not told that it's from her line of sight. So we are assuming that we don't have any height to add in at the end. She's going to walk back 35 more feet. So we don't know what this measure is. She walks back 35 feet more, takes an angle of elevation to the top of the building again, and because she is looking out more than she is up, that distance away from the bottom of the building has increased. This angle of elevation has decreased. It's now 51.8 degrees. And we need to find that height of the building. Alright, so we have two right triangles. We have this right triangle with a larger angle of elevation, shorter distance here that we are unsure what this is. And then we have this longer distance with a smaller angle of elevation. So our first triangle, we know this angle. We are finding the opposite side and the adjacent sides. This is what we're interested in. So we're working with tangent. So tangent of 74.2 degrees is equal to the height of the building over whatever distance x is. And then for our second triangle, we have a new angle of elevation, 51.8 degrees. It's equal to, again, the height of the building over, this time she is x plus 35 feet away from the base of the building. Now, what things do these two have in common? Well, they've got this value x, but they also have this value h. So I'm going to take advantage of the height of the building being consistent, and I'm going to solve each of these equations for h. Now, I'm going to do it the same way. I'm going to multiply both sides by x, and that will leave it solved for h. So h is equal to x times the tangent of 74.2 degrees. For my second equation, I'm multiplying this x plus 35. So here, h is equal to x plus 35 times the tangent of 51.8 degrees this time. All right. Now, because I know that the height of the building is consistent, it has not changed, I can say that h is equal to itself, right? So since we know that the height is unchanging, that means these two equations have to be equal to each other. So x times tangent of 74.2 degrees is equal to, now this is in parentheses, we're going to go ahead and distribute. So I've got x tangent 51.8 degrees plus 35 tangent of 51.8 degrees. So I distributed my multiplication over addition here to get both of these terms. Now, to find the height, I need to solve for x. which means I need to get these two values of x on the same side of my equation. They're not like terms because they have different angle values. So I can't just combine it into a single term here. Now, on the left side of my equation, I'm multiplying x by both of these tangent function values. That's a common factor that I can factor out. Just think college algebra where we were solving equations. It's just a little bit wordier than we're used to. Now, to solve for x, I just divide by this factor, which is the difference of the two tangent function values. Alright, this allows me to solve for x, which gives me the distance she was from the building for the first measurement. It doesn't give me the height of the building, so I'm not going to be done once I solve for x. When you plug this into your calculator, make sure that your denominator is in parentheses, or make sure that you do your denominator first and then use that second answer function button. However you need to do that, you should end up with a value of x, and I'm going to keep several decimal places to make sure that I haven't messed anything up, haven't rounded too soon. You should get this value for x, 19.65, etc. Now, when I plug this into my calculator, I'm going to start with my denominator. I tend to be untrusting of my calculators. So I'm going to start with my denominator, do 74.2, tangent of 74.2. I'm going to subtract from that the tangent of 51.8. That's my denominator. My numerator would be 35 times the tangent of 51.8. So that's my denominator. My numerator is 35 tangent 51.8. I'm going to hit enter and then divide that. That second answer function is not going to bring up what I wanted it to bring up because of that enter. I shouldn't have hit enter. That's going to mess me up. Yep. Okay. So let me plug that in again, guys. Here we go, practicing our calculator skills. There's not my denominator, there's my syntax error. Let's try again. 74.2 minus tangent of 51.8. That's my denominator that I need. Alright, so I'm going to do 35 tangent of 51.8, and I've got two parentheses open, so I'm going to close both of those and divide it by that denominator that I found. There we go. There's my value for x. And I'm going to use that to find the height of the building. Now, how am I going to use that? Well, I'm going to go back. I've got two different equations solved for the height of the building. This one's the one that's the simplest. So the height of the building is x that we just found times the tangent of 74.2 degrees. So there's my x times tangent of 74.2, and it gives me the height of the building. Now, 69.45 feet, but how many significant digits do we need? Well, when I go back and look, my angles are measured to 3 significant digits, but this distance value is just 2 significant digits. So I'm going to need to just keep my 2 significant digits here for the height of the building.